Alrighty, we are going to be completing a multi-step factoring of a trinomial where we have to use GCF and then X method to have it fully factored. So we are looking at this question 1 of 6x cubed plus 9x squared minus 15x. And then I do have this first reminder over here that we need our equation to be in standard form, which is ax squared plus bx plus c, to be able to use our X method. Now, the first thing I notice is that we have a value, a b value, and a c value that could all be divisible or factored by the same value. The second thing I notice is that our exponents are a cube, a square, and then the invisible 1, which in our standard form formula for the X method, we need it to be x squared, x, and then just the number. So we not only will be factoring out a whole number, but we will also be factoring out a variable. So to use GCF factoring, the way I teach it is I actually separate the items or the terms so I can keep things organized. And then the first thing we're going to do is actually find the GCF of 6, 9, and negative 15. Now you can use a calculator of some kind to locate the GCF of this, which the GCF is 3. 3 is the largest number that can divide all 3 of these items. So I'm going to start by dividing the coefficients by 3. So starting with 6 divide 3, that's going to give me a 2. And then I'm going to write out the x's. The exponent tells me how many to write. So x cubed means I'm going to write out 3 x's. Moving on to the next term, we have 9 divide 3. I'm going to start with that plus sign because it's a positive. And then it's going to be 3. And then x squared tells me to write out 2 x's. Now, last but not least, we have negative 15 divide 3. That is going to result in a negative 5. And then this x has the invisible exponent of 1, which means we are going to just write out 1x. Now, from here, we are going to circle what is in common in all 3 of these terms. All 3 of the terms must have the item that you are circling to be able to take it out as a GCF. The first thing we can circle is the number we divided by. So that 3 is the first thing I'm going to start with. And then I'm going to go ahead and rewrite that first. Then I'm going to look at the variables. Now, again, we must be able to circle the same item from all 3 terms. So if I go circle, circle, circle on my x's, I've just created one group of x's. Now if I try to make another group of x's, notice the last term has no more x's to create a group, which indicates that we are done finding things to factor out. In this example, we made one group of x's, so that's going to result in just an x. Then we're going to write what I call my leftovers inside of the parentheses. So I'm going to open a parentheses and locate all of my leftover items. Starting with the first term, we have a 2, and then we actually have 2 x's left over, which we're going to write as x squared. In our second term, we have a positive 3, so I'm going to do plus 3. And then we have 1 x left over, so I'll just put x. And in our third term, we have a negative 5 left over, and then there are no x's left over, so we are done, and we are going to close up the parentheses. This 3x that is on the outside of the parentheses is our GCF. So we have just completed the GCF factoring. However, we are not done factoring. We can still treat the inside of the parentheses as a trinomial and factor it using our X method. So that is what we will be doing next. Now I'm going to scroll down slightly. I have the X method kind of formula that I created for this on the side over here for us to reference as we are working through this problem. So again, we are only going to focus on the inside of the parentheses to complete the X method. So I'm going to draw out my X. Oops. And then on the top of our X is going to be that A times C. Oh, we should probably label this. So our A will be the 2 because that is with our X squared. Our B is going to be the 3 because it's with the X. And our C is negative 5, which again, you can reference up here how we found the A, B, and C. So on the top of our X, we have A times our C, which is 2 times negative 5. 2 times negative 5 will give me a negative 10. On the bottom of our x, we are going to place our b value there, which on this one, our b is 3. Now from here, we are going to answer what I call the riddle. We need to find two numbers that multiply to negative 10, but add to 3. For some people, the numbers can just appear in their brain and they can figure out the riddle, but for some of us, we need to write it out. So I'm going to go ahead and write out by taking negative 10 out, and we are going to create a factor T chart of negative 10. Now, the reason we are factoring negative 10 is because we need two numbers that multiply. And by creating a factor list, we are writing the numbers that multiply to negative 10. So, ignoring the negative just for a moment, we'll write out the factors of 10. We have 1 and 10, and 2 and 5. Now, because it is a negative, to multiply to a negative number, we only want one factor to be negative. So I'm going to start by making the smaller factors negative, so 1 and 2. But then I'm going to rewrite these factors so I can make the larger factor negative. So that way we can make sure we see all of our options so we can pick the right factors. Now, our goal after we get all of the factors right now is we need to add to 3. So it has to work for both criteria of multiplying to that negative 10, but also adding to 3. So let's go ahead and combine these factors to see which one will give us a positive 3. Negative 1 plus 10 will give me 9. Negative 2 plus 5 will give me 3. 1 minus 10 will be negative 9. And 2 minus 5 would be negative 3. Now again, we are trying to add to a positive 3. The only factor that gave us that positive 3 was this negative 2 and positive 5. So we are going to use these factors in our x method. Now factors are going to go on the bottom of the fractions on the side. Order does not matter. I'm going to put negative 2 on the left and 5 on the right, but order itself does not matter. You could put 5 on the left, negative 2 on the right, and still get this correct. Now from here, the next thing we need to do is we're going to place our AX on the top of these fractions. So our A, going back up to the question, is 2. So we're going to put a 2x on the top of both of those fractions. Now it's important that we check to see if they can reduce. So starting on the left side, 2 over negative 2 does actually reduce. Now, due to us writing these factors into factored form at the last step, so right here, we want to keep these as fractions. So instead of just writing 1x, or negative 1x, excuse me, I'm going to write it as 1x on the top, but then I'm going to keep a negative 1 on the bottom. And again, how I did this is I divided the top and the bottom by 2 to reduce. Now, to keep things organized, I do not want to use the original fraction. So I actually like to cross it out, and I'm going to circle my new fraction because I want to make sure I remember to use my factor or my reduced fraction answer. Now going to the other side, we're going to check, can 2 over 5 reduce? No, it cannot. So I'm going to go ahead and circle that factor so I can write it as my factored answer. So now to write these out as our final answer in factored form, starting with opening a parentheses, top will go first. So we have 1x. I'm going to make the 1 invisible by just putting x, but then the bottom of our fraction has a minus 1, and then close parentheses. Then I'm going to write out my second factor, which again, I'm going to open a new parentheses. Top goes first, so 2x. The bottom is 5. It's a positive 5, so I'm going to do plus 5, close parentheses. Now, the one thing I always notice that students will forget here is we had originally factored out this 3x using GCF. We cannot forget about this factor. We must drop it all the way down to put 3x in the front of our factored answer. So this one actually has 3 factors in total. 3x, x minus 1, and 2x plus 5. There are 3 total factors. Now this is our final factored answer for this question.